Super. Right. So we saw network address translation as the source address of every packet that goes out will, will be changed before sending out of your autonomous system. What is an autonomous system? Your network boundary. All the devices within your organization is inside the autonomous system. What is an autonomous system? All those devices that are working for a particular organization, all those devices that are managed by a single administration is autonomous system. Your office network is one autonomous system. My office network is another autonomous system. Now, what we learned is inside the autonomous system, we have private. Why? Because you don't have enough public address. So instead of buying public IP address for each and every device that we have in our organization, we simply put the private address, and before going to public, we translate on this router. Before sending the packet out, we put a public IP address as the source by removing that private IP address. For example, if I want to go online from A, computer A, I want to go online from computer A. What I do is I tell that use the IP address that is there on this WAN part, WAN side of the router. See our router. This side we call it as LAN side. This side we call it as WAN side. Now you are trying to talk to WAN, you are trying to talk to internet. So what we do is before sending the traffic out, we are asking to change to this public IP address. Let's say you have 20.0.0.1. Actually the traffic is coming from A. The source address is 10.0.0.1. But what the router do is, before sending the packet out, it removes the 10.0.0.1 and puts 20.0.0.1, and let's say it goes to Yahoo 60.0.0.1, and the traffic goes. And when the reply comes to 20.0.0.1, router knows for which address the translation happened, so it will do reverse NAT. Actually, the router will maintain a table called NAT translation table. Translation table. In that, it has maintained a table saying 10.0.0.1 I have translated to 20.0.0.1. So when the reply comes from Yahoo to 20.0.0.1, it knows what address to put so that the traffic will go to A. The reply traffic will go to A. The reverse NAT is automatic. We do NATing only from LAN to WAN. When the reply comes from WAN, the return traffic is sent to LAN automatically. Now, I also told you there are some type of NAT. There are different types of NAT. Static NAT, dynamic NAT, and dynamic NAT overloading. Three types I told you. Static NAT means what? One to one. See, the reason why we go for NATing is we cannot provide one to one. We cannot provide each computer a public IP address. We can't provide. It is only 32-bit. Providing IP address, a public IP address for everyone on earth is not possible. It will be possible only if Corona comes 1,000 times. Yeah. If Corona comes 1,000 times, then you can give everyone one public IP address. But Corona only comes once in 1,000 years, I think. So, we need some alternative. NAT is the alternative. So, NAT, what it does? It translates to one single address, you see. You may have 1,000 computers inside, but how many public IP addresses you bought? Only one. But the static NAT, static NAT. Static NAT is one to one. Now, why are we doing this? When we say we need NATing so that we don't need to buy too many public IP address, then how can I use static NAT? Yeah, we are not going to do static NAT for every device in an organization. We are not going to do static NAT for every device in our organization. There may be one or two important device which is accessed from outside. Only for that we give static NAT. I repeat. You are inside the organization. But this computer, this computer need to be accessed even from outside. The traffic is initiated from outside to inside. See, if traffic is initiated from inside, from A, the reply will come, reverse NAT will happen, that is okay. But if someone from outside want to talk to A, to which address they will talk? If I don't give a dedicated IP address, if I don't do one to one, how can someone from outside talk to inside? See, that's the purpose. If someone wants to access your device from outside to inside, you need a dedicated public IP address mapped to your private IP address. So we say whenever 10001 wants to go online, translate to 2000. Let's say I would like to give 2. Listen carefully. We have address 20001 on the interface. I am not using that. But if I want to use that, I can use it. I can use this. But I am not using that. I am using another one. I'm going to use another one. This one. This one I have purchased for my server inside the organization. 10001. This is my server. And this server I allow someone from outside to talk. So what I have told my router is, if anyone is pinging from here, from London, if anyone is trying to reach 20002, the traffic will come to this router. And this router maintains a table saying 10001 translate to 20002. It also means that if any traffic comes to 20002, I need to forward it to 10001 by changing the destination address. You understand? So we have a one-to-one mapping to solve the problem. One-to-one mapping. Any traffic going from 10001 will be translated to this particular address. Also, if anyone from outside send a traffic to this address, will be translated to 10001. Right, this is what we call it as one-to-one mapping or static NAT. See, the purpose is not only you talk from inside to outside, you also want from outside to initiate the traffic, talk to inside server. Whereas the other NATs that you are going to see can be only initiated from inside to outside, not from outside to inside. So in another word, what I can say is static NAT is bidirectional. Bidirectional. Static NAT is bidirectional. Now let us move on to next NAT called dynamic NAT. Dynamic NAT is you have many computers and all of them are connected to router via switch. Now what you do is here you create a pool of address pool. You see the original address is 10001. So you buy some, see here I have drawn only 3 computers. Take it as 300 computers here. How many? 300 computers. And you buy few address 200011, 200012, 200013. Only 3 address you bought. But how many are in your organization? 300 computers. You cannot afford 300 IP, so you bought only 3 IP. And you have put it in a pool. And now what you do in the dynamic NAT is anyone from inside can use any of the address from the pool, any of the available address in the pool before they go out. So for example, if B is trying to communicate to outside, it will say, router will say, I'm giving 10.0.0.2 20.0.0.11. It gives the first IP. Now the other two are still available for someone else to use, but 20.0.0.11 cannot be used by others because currently who is using it? B is using it. Let's say A is now coming 10.0.0.1. So the second address will be given from the pool. Now C is also trying parallelly 10.0.0.3. Available address is 20.0.0.13. Now what happened is there is another computer called D 10.0.0.4. D has Dhanaraj, Dandabani, Dindukal, Dinesh. Dinakaran. போங்கப்பா என்ன பேசினாலும் கரெக்டான பென்சில் வர மாட்டேங்குது. D. Now when D wants to go outside, there is no IP address in the pool. There is no IP address in the pool. என்ன கொடுமை இது. Only 3 address in the pool and the 3 is already given. When the fourth one comes, there is no address. Yeah, there is no address to give. So what will happen? It has to wait. It has to wait, and if address is not released by someone, it will time out and get dropped. That's the problem with the dynamic NAT. Dynamic NAT is too slow because it cannot go and use an address when there is no address. You have to wait till someone finishes their conversation in the network. So fourth one, have to wait. Now let us say B finished his conversation. B has finished the conversation. So the address will be released. Which address will be released? This address will be released because B has finished the conversation. So now 10.0.0.4 is going to use 20.0.0.11. Listen carefully. Earlier B was using it, but now D is using it. What do you understand? From outside, if someone wants to talk to D, they don't know what address to talk. Because the address will keep keep on changing. See, now if B wants to talk, there is no address. It will wait. And A finishes the conversation. So what router will do to 10.0.0.2, it will give this address now. Earlier it was using 11. Now it is using 12. நிலையான ஒரு அட்ரஸ் இல்லை, மாறிக்கொண்டே இருப்பதனால் வெளியே உள்ள நபர் எந்த அட்ரஸை கொண்டு பியோடு நான் தொடர்பு கொள்ள வேண்டும் என்பதை தெரியாமல் தொடர்பு கொள்ள முடியாமலேயே போய்விடும். That's the drawback of dynamic NAT. Dynamic NAT has got two drawbacks. One, it is unidirectional. Compared to static NAT, dynamic NAT has got this drawback. What? Unidirectional. Unidirectional. Second drawback is dynamic NAT overloading is slower because if the pool address is exhausted, the other trying to establish session have to wait. have to wait. Okay, so dynamic NAT is not used much. Not used. I can say it is not used. I've never seen. Static NAT, yes, we do use because we want sometime someone from outside to come and access your lab, your server, something like that. So what is used in the real world? After static NAT, dynamic NAT overloading. Dynamic NAT overloading is used. How is this solving the problem? The problem, there are two problems that we have seen. Number one, static NAT is good, but we cannot afford a dedicated IP address for every device in our organization. That is not possible. That is not possible. Providing every computer one public IP address, do we need it? First place, we no need also. Why? It's too costly. You don't have, first of all, addresses. So, static NAT is needed whenever you have few or one device to share with the public, so that public can also reach. You can also reach inside to outside, both outside to inside, both are possible. Dynamic NAT is you have a pool of address, only that many can go online at a given time. If I have 3 addresses in the pool, only 3 at a time can go online, and it has to wait for someone to release the address. The others have to wait until someone releases the address. And third type is dynamic NAT overloading. How does this solve the problem? That's what we want to see. Now I'm going back to the same picture. 10.0.0.1, 10.0.0.2, 10.0.0.3. These are all the computers. Now we are connected to a router, and we say dynamic NAT overloading. You know what does that mean? I'm going to give you one address, let's say 20.0.0.25. Use only this address for everyone. என்னது 3 அட்ரஸ் இருக்கும் போதே 4வது ஆளு பெப நிக்கணுமாமா அட்ரஸ் இல்லைன்னு. How is that possible? One address given to multiple people, and that too all will be simultaneously talking. How is that possible? It is possible when you mix port number with the address. So, dynamic NAT overloading, another word is PAT, port address translation. You see, when a PC communicates, you also have a port number, right, in layer 4. Let's say this guy is using port number 555 while communicating. This is using 6666. This is using 7777. So what this router will do, let's say A is asking for Amazon. B is asking for British Airlines. C is asking for Facebook. Now, for A, it gives 200025. For B also it gives same 200025. For C also it gives same 200025. But there is a difference now. In the previous two NATing, it did not focus on the port number that comes. This time it focuses on the port number also. Right. So it makes a note. Oh no. Who makes a note? Router makes a note that Amazon is requested by 10001 and port number of the person who requested Amazon is 5555. British Airways 6666. Facebook 777. Now listen carefully. Here is Facebook. Here is Amazon. Here is British Airways. Now when British Airways respond, it will respond to the port number 66666. So it knows that any traffic coming to this IP address with port number 6666, it should be translated to 10002. So British Airways response goes only to 10002. He's the original requester of British Airways. Likewise, when Amazon responds back, it responds back to the port number 5555 and IP address 200025, which is here mapped to 10001. So the traffic goes only to 10001, who is the original requester of Amazon. So you see the same IP address repeatedly overloaded. Along with the port number. So with the port number, you are able to differentiate. Even though the IP address is same, the traffic is not for the same destination, it is for different destination, and it is identified using port number. Did you understand? So in PAT, you don't need to buy too many addresses, you don't need to maintain a pool. See, you have port number up to 65,000, right? 65535. In that reserved port numbers are only up to 1024. So you can have 65,000 actually translations. But if I have 1 lakh, 1 million computers, then I need to buy two address, put it in the pool and use it as dynamic NAT overloading. So after that 65,000 translation, it will start using the second address. That will happen automatically. Yeah, so you need only one IP address, that's what I want to say. One IP address is enough to any number of inside device to go online. So there is no drawback in this is widely used. Dynamic NAT overloading is seen everywhere. Dynamic NAT, you need to wait only based on the number of address in the pool. Number of people can go online, others need to wait until someone releases the address, so it is low. And static NAT is 1-to-1. For some computers, we may need bidirectional communication. There only we go for static. Static NAT is only bidirectional. Dynamic NAT and dynamic NAT overloading is unidirectional. You can go only from inside to out, and response will be coming from outside, and from outside no one can initiate traffic. உள்ள இருந்து வெளியே பேசினா வெளியே இருக்கிறவன் ரிப்ளை பண்ணுறது நமக்கு வரும். ஆனால் வெளியே இருந்து ஒருத்தன் பேசணும்னு நினச்சானா முடியாது. ஏன்னா அவனுக்கு எந்த அட்ரஸோட தொடர்பு கொள்ளணுன்னே தெரியாது. நமக்கு தான் தெரியுமே, பூலில் இருக்க அட்ரஸ் அப்பப்போ மாறிக்கிட்டே இருக்குதே. ஸோ dynamic NAT overloading is slower. Dynamic NAT overloading is faster because it uses port number along with the IP address. So one address can be used for thousands of translation. We see in practical both static NAT and dynamic NAT overloading in use. Is there any question on this three type of NATing? I encourage you to watch my videos before you come to the next class, NAT lab. We are going to do lab, but I want you to watch a theory of NAT once again by me in different batch, so that it will be a kind of strong foundation of learning NAT. NAT is an important topic.